the critical issues in land-based mitigation are essentially what expectations we want to meet for bending the curve or reducing the warming or keep staying within a certain target. Basically indirect land use and competition for different types of land use. That's going to be the critical issues to keep an eye on. So looking at projections of future bioenergy use in that context, these are with respect to baseline in 2008, showing the total primary energy sources, energy supply from all sources. So this is the 2000 year 2000 total biomass harvested for food, fodder, fiber, and caloric value, and the 2008 global TPES from biomass. So those are the various levels in exajoules per day globally. So total primary energy is up here. This is the primary the biomass harvested, and this is the primary energy supply from biomass. In 2050, the technical potential is estimated by using these various models mentioned here with their various assumptions. These are basically the so-called integrated assessment models or life cycle models. The 2050 global biomass for energy under IPCC AR4 is in this range of 250 exajoules per day, and the total global primary energy supply under IPCC AR4 2007 is up here in terms of the projected needs. So the reports were called SRED, Special Reports on Emission Scenarios. In the AR4, the last one, last two, it switched to assessment reports 4 and 5, and now we are waiting for AR6 in 2021. Okay, so literature was synthesized looking for a range of theoretical technical potential ranging from 0 to 1500 exajoules. You can go and compare that with the primary energy supply now, which is around here at 500. So it involves population growth, GDP growth, efficiency changes, etc., to estimate these energy needs. Technical potential based on 2008 model and literature assessment for plant productivity improvements, marginal and degreed land, surplus good land, surplus forestry and agricultural residues and organic wastes. So these are the biomasses required for bioenergy by 2050. The potential development levels according to this review here is in this range, and then in terms of deployments that are projected to be needed to meet these concentration levels by 2100, ranging from 440 to 600 ppm or staying less than 300 ppm. What does it mean? Essentially, the contribution of bioenergy to the total primary energy supply has to go up considerably if you want to reduce the atmospheric concentration of CO2. Or you can also do it as CO2 equivalent, but typically we look at CO2. In the context of land mitigation, it just kind of brings home the message again that the competition for various uses have to be considered in terms of potential for land mitigation, as well as meeting the bioenergy demand in the future, which is all about the land biosphere, which we are worried about. Of course, there is a role for ocean biosphere as well that we are not considering here. Nonetheless, you get the sense that the it's a tall order to meet all these demands from land use and land biosphere. So in that context, we want to look at again the ecosystem services that nature provides us for free, provisioning, regulating, cultural, and supporting. So includes everything from clean water, fish, wood, pollination, natural defenses like control flooding, purifying water, especially running off from the land onto oceans through salt marshes and wetlands and mangrove forests, coral reefs, and so on. Storing carbon, clean air, education, recreation, aesthetics, habitats, biodiversity, and of course food supply. And it's needed for soil health and soil functionality as well. So then coming to the critical issues in land mitigation, this is looking at SRES projections or scenarios which did not consider land mitigation, whereas the RCPs did. And the various factors considered here are pasture, unmanaged forest, croplands, managed forests, and biofuels. Data-based land use change in terms of square kilometers actually is in here from FAO meat base and healthy diet base in terms of the land use. So that's the critical land-based mitigation issue. When you want to do livestock, you need grazing, you need food, fodder, grain, etc. for the livestock, which is environmentally very expensive. So there is a competition between producing food as meat versus land use for other uses like grain production or forest land and so on. Okay, that has to be estimated from data as well. And for data, I think we don't have much for unmanaged forest. That's what it says up here. So you can see the change in the land use expected from expected under various SRED scenarios which were used in the 2007 report, 2007 SRES, I think it was called Third Assessment Report, TAR. AR4 in 2014 used the 2.6, 4.56, and 8.5 scenarios with these ranges of land use change for meeting the demands. For example, to stay within RCP 2.6, these are the land use changes that you need to stick to in terms of these various categories. And when you go to RCP 6, it is somehow much higher than RCP 8.5 because that depends on the details of how the various factors that go into the scenarios are accounted for in terms of energy portfolio, technologies, population growth, etc. Okay, so these are the various models here. The Quest GloBiome baseline, it's the 500 bioshock. Basically that means a increase in energy supply from bioenergy. Okay, increasing the amounts of bioenergy by 50% is called 50 bioshock, and this is with red, so reduced emissions from deforestation and forest degradation. Okay, so what is it saying? It's basically saying we still have to rely on models with all their warts for future projections of potential of land-based mitigation in looking for critical issues involved in those. So this is selected co-products from the use of crops for transportation, biofuels, and their uses. Biofuel crops go from cereals, sugar beet, rapeseed, oil palm, sugarcane, lignocellulose crops like willow and switchgrass, and so on. There are various ideas on growing these on wastelands, abandoned lands, unused lands, and so on. So there are ways of adding carbon in places which are usually not carbon sinks. That elevates the mitigation potential, of course. In terms of co-products, you have distillers grains, sugar beet pulp, rape meal, empty fruit bunches, palm kernel expeller, bagasse, lignin, and so on, and used in various sectors like high protein animal feed to improve the meat volume and quantity and quality, solid fuel, They replace soy meal and other protein feeds, electricity and heat. High-calorie animal feed is substituting wheat and other feeds, which could balance food security, for example. Animal feed replacing soy meal and other feeds. Chemicals replacing petrochemicals. So these are byproducts of bioenergy or residues from bioenergy crop use. So this is an attempt at making the life cycle more sustainable in terms of reducing the potential for loss of carbon from the system and enhancing the mitigation potential. Every little thing has to be tracked and made sure that the system actually does provide mitigation potential, or that we accomplish the full mitigation potential of the land biosphere. Okay?